Hello, you're welcome back to my channel. Thank you for stopping by again. This is the second part of this series on answering exam style questions that require no calculator. Question number 5. Here we have a trapezium. Now we've been told to work out the area of the trapezium. The formula for finding the area of a trapezium is given by 1 over 2, the sum of the two parallel sides multiplied by the height. Now, in this particular trapezium, we have our 1 over 2 here. The parallel sides are lengths 11 and 7. So I'm going to have 11 plus 7 in the bracket multiplied by the perpendicular height. Remember, the h here implies perpendicular height, so multiplied by 6. That is 1 over 2 times 18 times 6. Now 2 here, 1, 2 here, 3. 3 times 18 is 54. So the area of this trapezium is 54. Please don't be tempted to start measuring anything. Remember, it is clearly stated here that this is not to scale. Okay, on to the next question, question number 6. Here we also have a triangle, but with a little twist. All right, now here we have AB equals to BC. We're being told that AB is equal to BC. What's the implication of that? It means this line is equal to this line. You can see those two dashes there. Now, what is the other implication? It means triangle ABC is an isosceles triangle. If triangle ABC is isosceles, then it implies that if the angle at C is X, the angle here will also be X. Why? The base angles of an isosceles triangle are equal. So if that is X, the angle at A will also be X. All right. But that is not what they asked us. They actually asked us for the value of X. Another theorem or another concept about triangles is that the external angle, that is the angle 50, the exterior angle is the same as the sum of the opposite interior angles. Let me take that again. The exterior angle of a triangle is equal to the sum of the opposite interior angles. Now, the opposite interior angles here are what? X and X. So their sum will be X plus X is the same thing as what? The exterior angle, which is 50. So we know that 2x is equal to 50, and that gives us our x equal to 50 over 2, which is what? 25. All right. Another person might assume that, oh, I don't think I want to do it that way. I know this is 50 here, and this is a straight line. Angles on a straight line should add up to 180. It means if this is 50, the rest of this is what? 130. Now, if that is 130, and yes, this is still an isosceles triangle, we know that the sum of angles in the triangle should be what? 180. So 180 should give us 130 plus x plus x. So 180 equal to 130 plus 2x. 180, if this 130 comes over here, it becomes negative. Minus 130 equals to 2x. 50 is equal to 2x. And therefore, 25 equals to x. Observe that whichever way we do it, we're still going to have our x as 25. And here we have write 0.00067 in standard form. The thing about standard form is this. When you're asked to write a number in standard form, the very first number you will write, let's call it A. Your A should be greater than or equal to 1, but it should be strictly less than 10. All right. So it means whatever number you're going to write before you say times 10 raised to power something, it has to be between 1 and 10. So here we know that the number we need to write should be here. It should be 6.7. Okay, because that's what falls into this range. How many times are we going to move the decimal point to get there? 1, 1, 2, 3, 4. we are moving the decimal point 4 times. So that is why our answer will be 6.7 times 10 raised to power 4. No, it is minus 4. Why is it minus 4? We are moving our decimal point to the right. When you move to the right, then it is negative. When you move to the left, it is positive. So since we are moving to the right, it's negative. So our final answer here will be 6.7 times 10 raised to power 4. All right, so that's that for this session. See you in the next one, where we'll be looking at question number 8. It's about fractions again. See you in that video. Take care. Have you subscribed yet? Please do. Thank you for watching. Bye.